I would like to introduce Professor Martin Fischer from Stanford University to give the conclude remarks for this workshop. Martin, you're muted.
Yep. Thank you, Yelda. And I realize we're a little bit late, so I will try to make this quick. Yeah, I was reminded in this workshop once again about the mutual beneficial relationship between CVPR and construction research and practice. Sort of what I saw is the CVPR community has many solutions to offer. It's not always, as panelists also commented, that easy to find them from the construction side of things. But my experience with working with computer scientists is that they are looking for power and generality of their methods that gives them bragging rights. And so for that, they need a wide range of scenarios. And I think that's something we can offer in the construction industry. If I think of it, when I say construction, I mean very, very broadly, not just putting a couple of bricks together. I really mean creating and improving the built environment. As you saw from the examples over the course of the workshop, we have quite a few problems to offer, from turning a idea into a digital, more solid idea into reality, and then improving upon that. Many types of information, many uses of information, and we need robust solutions that scale. Because if we don't have that, then I think Eleni reminded us really in her talk very nicely about the importance of the built environment to society and the challenge of innovating in the industry, which then creates this spiral effect, down spiraling effect, because not being innovative makes it less attractive to good talent, which lessens its performance, which lessens its impact on society. But I think what we saw today, also from Eleni's vision in terms of the role of information processing to address this challenge, but also from all the speakers and those participating in the challenge, that indeed, with technology, I think we can address this important societal and industry challenge. So we saw then in the other keynotes several specific concepts in terms of turning ideas to reality and improving them, like from making architectural knowledge available more widely by Yasu, to making construction more efficient by Derek, to reducing detrimental climate change impact of the built environment by Frederick. Connecting some of them sort of, I wonder what we can take this offline, but I was kind of wondering if we could we create regenerative design methods where Yasu's methods would learn from existing buildings what is a good building and automatically reconfigure good ones to become even better, maybe with some of the methods that Frederick showed and performance that Frederick addressed, and of course reconfiguring those that are not performing so well to become better. I can definitely see a performance-focused digital twin kind of world ahead. That's where my mind was going as I was listening to the speakers. The challenges showed there is still quite a bit of effort required for turning point cloud data into actual information, which reinforced the point that Derek shared through that he had heard from Brian Krause, one of the main innovators in the US construction industry, to take methods out of the lab and test them on real world problems. I think we saw a glimpse of that and the challenge that we still face of really having scalable, robust methods. It reminded me a bit of a whodunit detective game, as I listened to the approaches. It seemed like there was many turns you could take, listening to it from a just construction perspective. But over the course of the afternoon, for me, in my time zone, I learned a lot. And I want to thank the workshop and challenge participants, keynote speakers, panelists, moderators, for the learning they've provided to me and also hopefully to you. Also want to thank my co-organizers. It was a lot of fun, deepening collaboration with some of you and getting to know new collaborators. So we hope to do future workshops. we've had some initial ideas for some topics here, and my colleagues, please jump in. To further develop the 3D evaluation, for example, with topological metrics, include more important, challenging types of semantics. Many of these topics were alluded to over the course of the afternoon. And extend tasks to include scene graph prediction tasks, like semantic and instance segmentation of building elements, object attribute prediction, scene graph estimation. We could also introduce AEC focused metrics. Several were brought up over the course of the afternoon, a bit more into challenges. But all of this would, I think, require more data and better annotations. And hopefully it's okay, Fu-Shin, if I suggest that those that would like to possibly help with that, contact you.
Yeah,
so that,
thank you.
With that, thank you again, everyone, for attending the first workshop and challenge on computer vision in the built environment.
Right. Thanks a lot, Martin. Yeah, definitely. Let me know about if you want to, if you are interested in sharing data, we can talk about privacy issues. And then in this case, in this particular data set, we also had to deal with some privacy issues. We had to do some kind of changes to the layout of the building so that it doesn't actually reflect exactly as in reality. And then, yeah, there's some anonymity we have to do. So we are looking forward to solving those challenges. So yeah, definitely let me know. Thanks.
And with that, I guess we conclude our workshop. Thank you everyone for being here. And I hope to see you next year.
Wishing a good night to some of you. Good rest of the day.
Thank you.
Yeah.
Well done for the workshop.
Yeah, thanks all the keynote speakers and Marcia for kind of moderating the panel, and thanks for all the people, challenge winners who participated, participants who participated in the challenge, and thanks everybody who participating in the workshop.
Thank you.
Yeah, take care.
Thank you all. Bye.
Bye, everyone.
Bye.
Okay.
All right.
All right. Okay. Let me stop recording first.